Everyone, today we're going to talk about how to calculate binomial probabilities. But before we do that, we need to talk about what a binomial random variable is. So to be considered a binomial random variable, bi meaning two, we have to have a probability of success and a probability of failure. Only those two things. So you can think about it as maybe a yes or a no survey, flipping a coin and getting heads or tails, the success rate in an experimental drug trial, or maybe even the probability of sinking your next free throw. So a binomial random variable counts the number of successes in a sequence of trials. And there are some conditions. The number of trials has to be fixed in advance, and that's our variable n. The probability of success can't change throughout the whole trial, and that's p. And the successive trials have to be independent of each other. So if I want to find out the number of heads in 2 coin flips, my n is going to be 2, and my probability of success is going to be 1/2. If I want to find the number of 6s in 5 dice rolls, my n is going to be 5, and the probability of getting a 6 is going to be 1/6. So the mean for a binomial random variable is just n times p. N being the number of trials, and P being the probability of success. So in this example, for the number of 6s in 5 dice rolls, I would take 5 times the probability of success, which is 1/6, to get 0.833. But what about standard deviation? So the standard deviation for a binomial random variable is the number in your trial times the probability of success times the probability of failure, and then taking the square root of that. So for the number of 6s in 5 dice rolls, to find the standard deviation, I would take 5 times 1/6 times the probability of failure, which would be 1 minus 1/6, and then I would take the square root of that to get 0.833. So let's take a look at an example of the use of the binomial model. Suppose that 80% of adults with allergies report symptomatic relief with a specific medication. If the medication is given to 10 new patients with allergies, what is the probability that it is effective in exactly 7? So first off, are our 3 conditions met? The outcome is relief from symptoms, so that is just a yes or a no, a probability of success and a probability of failure. Number 2, the probability of success is 0.8. And number 3, are these independent of each other? Are the adults in this trial independent? And they are. So what do we know? Well, there's 10 observations, so n equals 10. The successes of the events that we're interested in is 7, and the probability of success is 0.8. Luckily, we can use our TI-84 calculators to calculate these probabilities. So you're going to be using the distribution function. So to access that, you're going to push second and then bars. Scroll down until you find binom PDF. Binom PDF is a binomial probability distribution function. N is the number of trials, P is the probability of success, and C is the number that we're actually looking for. So in our case, from the example on the previous slide, we had 10 patients, there's an 80% success rate, and we wanted to know the probability that exactly 7 patients found relief. By putting this into my calculator, I get about 20%. Binomial CDF is slightly different because now we're talking about a binomial cumulative distribution function, which means we get to add up all of the probabilities before it to find the cumulative amount at that value. Let's take a look at a couple examples. Trials is still going to be 10. My percent success is still 80%. But what if I want to find the probability that less than 7 patients found relief? Or maybe more than 7? Or maybe between a few numbers? So we can use binom CDF to do some of these calculations. First off, if I want to do less than 7, what I'm really finding is up to 6. So I'm going to have binom CDF 10, 0.8, and 6. And that's going to give me roughly about 12%. If I want to find more than 7, remember that we're talking about a cumulative frequency. And so this is up to 7. And so this is going to look a little bit weird. I'm going to go 1 minus the binom CDF of 10.8 and 7. And that's going to give you the value of more than 7. It's almost like the complement. And now the last one, if I want to go between 4 and 7, this is where it gets tricky. What I'm going to need to do is I need to take the binom CDF of 10.8 and 7. That's going to give me the values all the way up to 7. And then I'm going to subtract out binom CDF of 10.8 and 3, because that's going to take out that lower end of data that I don't want anymore. So just remember, when you're finding binomial probabilities, it's okay to use your calculator. And you're going to either use binom PDF if you want to find the exact value, or binom CDF if you want to find the cumulative value, or the probability of C or fewer successes. Good luck!